Hey Algebra 2. So this will be the first of a few video lessons. I'll be out for a few days for my wedding. So some things that you can expect while I'm gone are that I'll be making video lessons for you guys every day. I don't want you to fall behind. Mr. Ortiz is still going to be here teaching his Algebra 2 class. There's a lot of things in our curriculum, and it would just be very rude of me to leave you guys hanging and not teach you anything. You can also expect homework. So you guys will still be doing homework. I'll be assigning it just like regular. Class is not going to feel that different. It'll just feel like I'm teaching from the back of the room, and you can't see me. I will not bother with homework checks while I'm gone, so homework checkers, you don't have to worry. You can relax. I'll check it all when I get back. You can also expect that there will be no remind messages. Sorry guys, I can't necessarily rely on my schedule or rely on having service all the time, so you won't be getting any remind messages. You could always refer back to these videos to remind yourself what the homework was, okay? Because these will all be archived on YouTube and you can access them anytime. Sorry about that. When I return, I will check all of the assigned work. So that means any classwork, any homework that I assign, I'll be checking all of it, even if it takes us a whole bunch of time, because it's important to me that you're actually getting out of this what I'm wanting you to achieve. Another important thing is that after we do a quick review, you'll be getting a quiz on all this. So it's important that day to day you're holding yourself accountable and making sure that you're learning what I think you should be learning. Okay? If you have any questions, of course, you could always rewatch the videos at home or borrow a laptop during office hours and watch the video there. You can also feel free to ask Mr. Ortiz questions, considering that we're covering the same curriculum. He should be able to answer them as well as I can. Okay, so now we're going to get started on our first lesson in my absence, which is lesson 29, simplifying rational expressions. So, Proctor, you can pause if you'd like while everyone takes out their notebooks. I'm going to start off on the first section, which is simplifying regular fractions. If you could pause, Proctor, I want everybody to take 2 minutes. Let's give you 2 to 3, because I don't know how long it'll take. I'm not there. Give you 2 to 3 minutes and simplify all of these. If you're back watching me, I assume that you've already completed a few of these, and let's walk through how we do them. In order to simplify question number 1, 3 over 9, you may have thought of it just simply as dividing both the top and the bottom by 3. You might have said, oh, well, divide by 3. Let me zoom in a little bit more. And divide by 3. And then that gets you 1 over 3. Another way that I like to think of this is in the terms of GCFs, or even just regular common factors. So when I'm looking at something like 3 over 9, I like to think of it like this. 3 over 3 times 3. And what I can do is I can cross out on the top and bottom. This is an essential skill that we're going to be using for this whole week. Okay? So the answer to number 1 is 1/3. I'm going to do something similar for number 2. A common factor of 4 and 14 is what? 2. So this can become 2 times 2, and this can become 2 times 7. What I can do is when I have 2 divided by 2, those are going to cancel each other out. And my answer is going to be 2 over 7. Let's try that one more time. My GCF for 10 and 50 is going to be 10 on top, 10 times 5 on bottom. The 10 and the 10 can cross each other out, leaving me with a placeholder of a 1 on top. And the answer would be 1/5. I mean, I'm sure you looked at this and you already knew it was 1/5. But this is how I want you to think of it, because it'll help prepare your brain for what we're going to do next. Number 4, our GCF would be 3, right? 3 times 4, and 3 times 10. I hope you caught that 3 was not actually the largest common factor. If you caught it, you can give yourself a pat on the back. 6 is actually our common factor. 6 times 2 on top, and 6 times 5 on the bottom. If you cross out the 6's, I get 2 over 5 again. I want to explain two things when I'm answering question number 5. What is the general process for simplifying rational expressions? And I also want to explain to you what a rational expression is. So question number 5. A rational expression, I like to think of them phonetically. Rational sounds to me like fractional, and that's how I always remembered it. Rational, fractional. So a rational expression is a fraction with algebraic expressions sometimes polynomials, on top and bottom. Okay, so rational, fractional, so that tells me I'm talking about fractions. It's a fraction with algebraic expressions, sometimes polynomials, on top and bottom. The general way that we simplify these is to factor top and bottom independently, then we cross out like factors on top and bottom. Factor the top and the bottom independently, then we're going to cross out like factors on top and bottom. So let's go into an example from there. I'll rewrite it over here so you can finish writing these notes if you are still working on those. Pull question number 6 over. I'm just going to rewrite it so that I can 36, I like capital B's, capital B cubed, over 48b. Okay, so number 6. We have 36b cubed over 48b. So these are both algebraic expressions on the top and the bottom, just like I said. So that makes this a rational expression. What we're going to do is we're going to try to factor and then cross out like factors. So what we're looking for is we're looking for like factors. Can you think of anything that's like that you can divide both 36 and 48 by? We're talking about common factors. So 36 and 48 can both be divided by 12. So what I'm going to do is I'm going to factor this as 3 times 12 b cubed over 4 times 12 b. Now I have a 12 on top and a 12 on the bottom, so I can cross them both out. The reason why is because 12 divided by 12 is 1, right? And multiplying all of this by 1 over 1 wouldn't change anything, so why bother? So 12 and the 12 cancel out. And there's one more simplification that we can make. Not the 3 over 4, but the b cubed over b. So this is going to become 3b times b squared over 4b. And I've got 1b on the top and 1b on the bottom that can cross each other out. My final answer is going to be 3b squared over 4. And that's as simple as it's going to get. Let's do one more. Question number 7. This one is so simple, I'm not even going to bother pulling it to my notes. 70 over 70. Same on top and bottom. They cross out. So this is equal to b squared over b cubed. Fix up that ugly 3. What do I have on top? I have a b squared. On the bottom, I have a b squared times b. So I can cross out the b squareds. I'm left with a placeholder of a 1, because you can't have nothing on top, otherwise it's not a fraction anymore. So I've got 1 over b. Okay. Now, pause the video. I want to give you guys 3 minutes to try to complete questions 8 and 9. You have 3 minutes. Go. Okay, so hopefully you finished 8 and 9 in that 3-minute pause. If you didn't have a 3-minute pause, you should pause this video and give everybody time to work. Now, for questions 8 and questions 9, let's see if you did it right. Question 8. I can divide it by 12 on top and 12 on bottom. So I get 12 times 3. P to the 5th over 12 p to the 4th. The 12s cancel out. I can also rewrite the p to the 5th. When you get good at this, you can do multiple simplifications at once, but for now, let's take it one at a time. 3 times p to the 4th times p. So I still have a p to the 5th on top, and on bottom, I just have p to the 4th. Now the p to the 4ths can cross out, and my final answer is 3p over 1, or you could just write 3p. Question number 9. I'm looking for a common factor for 45 and 63. Well, 45 is 9 times 5, and 63 is 9 times 7, so I think that our common factor is going to be 9. So on top, I'm going to make this 9 times 5. I'm going to break up the r cubed, because I know what's going to happen. R times r squared. On bottom, I break up 63 into 9 times 7 times r. Now I cross out anything that's the same on the top and the bottom. Cross out the 9s, cross out the r's. My final answer is going to be 5r squared over 7. Now the real goal of this isn't to just simplify monomials, right? These up here were all monomials. They were single terms. What we're usually doing is we're doing polynomials. The Regents loves these questions because they encompass a couple of different skill sets. For instance, question number 11. If you look at the top here, you should just automatically see what you can factor that into. The bottom is a little bit more complicated. I'm definitely going to want some space, so even though I did the last couple on my sheet, I definitely want to be on my loose leaf. So let me rewrite this, and I'll pull it to my loose leaf page. P squared minus 16 over 2p squared plus 4p minus 16. And grab that with my selection tool, copy that out. And that was question number 11. Okay, so for question number 11, what I have to do is I have to factor. I don't want to divide this. I know that this right here might look like division to you, but I don't actually want to divide that. I can make my life a lot easier by factoring. Remember that our goal is just to factor and then cross out. So here's what we do. The top, if you didn't see it, is p plus 4, p minus 4. Remember that this right here is dots, difference of two squares. So it's like you're square rooting this and square rooting this. That's where the p and the 4 come from. The p and the 4. All right. On the bottom, did you notice the GCF? What can all three of these terms be divided by? They can all be divided by 2. So p squared plus 2p minus 8. Now we're not done yet. If you look at the bottom, can you see what type of factoring might work on that? This has a 1 in front, so we can actually just use add and multiply factoring. So we can use double bubble. So here's what I'm going to do. I'm going to take the number -8, and I'm going to say, hey, what multiplies to give me -8? Well, it could be 4 times 2, one of them being negative, right? Could be 4 times -2. And I'm looking for things that will add to 2. Oh, well, these add to 2. 4 and -2. So what that means is, then on the bottom here, I can just sort of carry this 2 over. This, that I'm underlining with a squiggly, can be rewritten as p plus 4, p minus 2. I rewrite the top, p plus 4, p minus 4. And maybe you notice something. This and this are the same. So I'm going to cross them out. Is there anything else like, similar, top and bottom? Nothing identical. So my final answer is just going to be p minus 4 over 2, p minus 2. One more of those, and then I'll give you some practice time. Question number 12. Copy that question over. R squared plus 5r plus 6 divided by r cubed plus 6r squared plus 9r. Okay, so remember, my goal, as I wrote in my notes already, is to factor the top and the bottom independently. So I'm going to factor the top first. What adds to 5 and multiplies to 6? If you need to write that out, you can. So factors of 6 be 3 times 2. Oh, and 3 plus 2 would equal 5. So the top is going to be, I'm going to write capital R's. I don't like these lower cases. R plus 3, R plus 2. On the bottom, the first thing that you should notice is these all have a GCF of R. So I'm going to pull out an R, and then see what I have left. R squared plus 6r plus 9. Now, I bet you that I can double bubble factor that. So let's see. R squared plus 6r plus 9. What adds to 6 and multiplies to 9? 3 and 3 do. 3 times 3, right? And 3 plus 3 would be 6. So this is r plus 3, r plus 3. So I'm going to throw that back up in there. I'll rewrite this. This is going to be equal to, I'm just rewriting the top, r plus 3, r plus 2, divided by r plus 3, r plus 3. And once again, the final end goal is being able to cross things out, because this is a lot simpler than when it first started. My final answer is going to be r plus 2 over r plus 3. Okay. Take a few minutes, complete questions 13, 14, and 15. So pause it for 5 minutes. 13, 14, 15. You should be done with those by the end of 5 minutes. Go. Okay. If you're back watching this, I assume that you've just unpaused the video and everyone's completed 13, 14, and 15. So let me briefly go over those. Here's what happens on 13. Remember that I am not teaching you this question. I've already done that. I'm just reviewing. On the top, I can factor out a 3. That gives me n. Ooh, even better. Look, I've got an n in each one of these too. I hope you noticed. Sliding over. Okay, cool. So I'm going to factor out a 3n. That leaves me with n squared minus 2n minus 8. And I do a little bit of a mental distribution to make sure that I would get back what I started with. Yep. Okay, cool. I didn't mess any of this up. Always good to check. On the bottom, what adds to negative 2 and multiplies to negative 8? So let's see. Negative 8. It can be negative 4 times 2. And those would add to negative 2. So this is n minus 4, n plus 2. Nothing alike yet, because I still have to factor this. Two things that add to negative 2 and multiply to negative 8. Didn't I just do that? I did. So this is equal to 3n, n minus 4, n plus 2, over n minus 4, n plus 2. I'm able to cross out both these n minus 4s and also the n plus 2s. And my final answer is just 3n. I hope you were able to get that. If you're having any trouble with this, you may want to go back to some of the lessons on factoring, okay? Because that's really all we're doing here, GCF and double bubble factoring. I'm going to add these two on as homework questions, 16 and 17. No time to do them now, just circle them on your paper. We have to move on to grouping. Factor by grouping works the same way. So for number 19, I'm just going to rewrite this. I'll give you one example. You could always go over it later when you're doing your homework. Rewatch this section of the video, just sort of skip around. I don't want you to watch the whole 30-minute video again. On top, I'm going to get 2 n squared as a GCF. That leaves me with n plus 3. I do a mental distribution just to make sure I'm still right, and it seems like I am. On the bottom, you're going to notice that you have a GCF of 3. So if I divide out a 3 and an n, I'm going to be left with 2n squared plus 3n minus 9. I do that mental distribution back in to make sure that I'm right. If it takes you a second to do the check, it's worth it. And now I see that this ugly thing here has a 2 in front. How rude to have a 2 in front. Well, considering that you just took the IA, we did all that review, we did this factor by grouping, and hopefully you were able to do that on the test, you should know how to factor this. If I take something like this, 2n squared plus 3n minus 9, and I need to factor it, what I do is I look at the coefficients. This is A, this is B, and this is C. I multiply A times C. A times C, that's 2 times negative 9, that's negative 18. Now I look for factors of negative 18 that will add to 3. So what can get me 18? I can do 9 and 2, I can do 6 and 3. Well, 6 and 3 are 3 apart, right? So let's see, if I play with the negative sign, I want it to add to positive 3, so I'm thinking positive 6 and negative 3. 6 minus 3 is 3, and 6 times negative 3 is negative 18. Yeah, those are my numbers. So those are going to be my numbers. I'm going to split the middle term, split it, into a 6n minus 3n. If you combine those like terms, it would give you this back. That's how I know I'm right. And I bring down the other two terms, 2n squared and the plus sign, and I bring down the minus 9. I now have 4 terms, and I can factor it by grouping. When I factor it by grouping, I'm going to erase a little bit of my scratch work over here. I'm going to get 2n, n plus 3. I can factor out a negative 3 on the left-hand side, so negative 3, leaving me with n plus 3. So the final factorization of this is outside stuff, 2n minus 3, and inside stuff, n plus 3, and that is what this is equal to. See, you thought I taught you all those factoring methods and we were just going to forget about them. No, 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 no. We need to keep using those. If you're rusty, you need to brush up. There are videos on these. So when I rewrite this, I get 2n squared, n plus 3, over 3n two n minus 3 n plus 3. Now I can do a couple things. The n plus 3's are going to cancel out. And this is the way that we do this in practice. I have an n on the bottom, cancels out one of the n's on the top. So instead of rewriting this as n times n, I usually just do this. One of these n's cancels out one of these n's, dropping it from an n squared to a regular n. Okay, it's like I did this, n and n, and I just crossed out one of them. So my final answer is going to be 2n over 3 2n minus 3. Now I know that we've got to be running out of time in the class. Hopefully you've made it to this point. So let's make our final 2 homework questions. I don't want to do a second grouping one on the back. Rather I do. Let's just do these two, 32 and 33. Okay? So you have 16 and 17, 32 and 33. If you have any trouble with those, watch this video over, jump around until you find the question that you want in the correct section, and then I will sort of, kind of, not really see you tomorrow with another video.